Hey guys, welcome to my series on Spark AR scripting. We're going to be going through a bunch of different topics on how you can create your own effects in Spark using scripting. My name is Sohail, and you can find all my filters on Instagram at SohailMehra or click on the link in the description below. I made all of them entirely in scripting, and after this series you'll probably be able to do the same if that's what you want. As far as scripting goes, Spark uses JavaScript, but it's a type of paradigm known as reactive programming. I'll cover that in a bit more detail later, but for now, it just means that instead of creating all the logic for your effect in your script directly, you're basically just creating a bunch of connections between objects and events, which tells the Spark engine how to run your effect. It's kind of like creating a patch graph in a text editor instead of a patch editor. So as your projects get bigger and bigger, this becomes much easier to maintain and edit and rapidly iterate on. It also means that if you're already familiar with patches in Spark, you most likely already know how scripting works. It's just a bit of different syntax, which you need to learn first. But I'll cover all the details and show you how that all actually works. Alright, so let's get started. Before that, we're going to need some kind of text editor in which we can type our scripts in. If you already have a favorite text editor, that's fine. But if not, I would recommend downloading Visual Studio Code by Microsoft. It's free, it's open source, and it runs on any platform. It's also recommended by the Spark team as the go-to editor for creating Spark AR scripts. Also, I would recommend, as you watch the video, try and follow along. So if I'm typing some script out on the screen, I would say follow along at your own pace and type it out along with me. It's much easier to learn scripting if you type it out instead of just watching a video. But if you'd like to just watch the video first from start to finish and then come back and type along, that's fine too. Okay, so let's go over to Spark. I'm gonna create a blank project, and for this first effect, I'm just thinking of creating a simple screen effect which just takes the camera texture and outputs it to a rectangle on the screen. It's super easy, but it'll make it easier for you to learn the basics of scripting, and as we go forward, I'll start doing more and more advanced effects. Okay, so you should see something like this. First, I'm just going to delete the lights because we're not going to need any of the lights. Then what we're going to do is add in a canvas which lets you group 2D objects together, and then we're going to add in a rectangle which lets you display material on the screen. So I'm just going to set this to fill the width and the height. Okay, then what we're going to do is create a material for that rectangle. And we're also going to extract the camera texture because we're going to need that. Okay, so now what we want to do is basically take the camera texture. So I'm going to drag it into the patch editor and take the material, set its diffuse slot to the camera texture. So what we're going to do is sample the camera texture at the texture coordinates of the rectangle and output it to the screen. So for that, we're going to need, it's in the shaders module, it's something known as Vertex attribute, which gives you the texture coordinates for whatever object you're applying the material to. So we're going to take the vertex attribute and then feed it into a texture sampler, which lets you sample a texture at a specific set of UVs. So we'll pipe in the camera texture to the texture and then the texture coordinates to the UVs, and then we just feed it out to the diffuse texture of the material. And what we need to do is set the shader type to flat. And okay, I guess I need to reconnect it. So there you go. As far as a flat shader type, it just means that it's not going to use any of the spark lighting, versus the other shader types like standard and physically based, they all use lighting computed by Spark. For this first effect, we don't have any lights, but later on in the series, I'll show you actually how to create your own lights in shader, in your shader code, and then you'll have much more control over what you can do with them. So now what we're going to do is try and recreate this in a script. So let's create a script, and to do that you just do add asset and script, and then it'll create the script.js file, but there's not going to be anything in there. So just double click on it, and it's going to open it in the default text editor you have for .js files. If you don't have a default text editor or it gives you an error, go to your file explorer and set the default program for .js files to whatever text editor you're using. In my case, it's Visual Studio Code. Alright, so when it opens, you're going to see this file basically, which has a bunch of text in there already. This was added by the Spark team to make it easier for you to get familiar with scripting and stuff. So these two links over here, they're the scripting basics and the reactive programming guide. If you've never scripted before or you're new to scripting, I would recommend reading these. They've got a lot of useful information which will help you as you're creating your own scripts. Then this link over here, that's the scripting object reference. It contains all the information for how the different scripting modules in Spark work. Kind of like the patch documentation. When you click on the patch editor and type in something, it shows you a bunch of documentation. It's the same thing but for scripts. So this is something as you're scripting you'll keep opening and looking up things in. And just a note, these double lines here, that's basically a comment. So in scripts you have comments like this and executable code. So anything in a double line or a line and a slash, a star, sorry, so a star and a slash, that's basically a comment, and that's just like a note to yourself. It's not actually going to run or do anything in your script, so you can have as many of these as you want. Now I'll just walk you through what's going here. So we can basically delete all this. We don't really need it. So over here, what it's doing is loading in the Sine module. So modules in script is like how in patches you have the different categories and they let you interface with different functionality in Spark. So the Sine module lets you talk to Sine objects. The shaders module lets you create shaders and materials. And then there's the animation module which lets you create animations and so on. So this const Sine over here, that's declaring a variable, and it's doing const Sine equals require Sine. So require is basically loading in the Sine module and creating a reference to that and assigning it to the variable Sine. So now every time you want to do something in the Sine module, you access it through the Sine variable. As far as variables go, there's two types of variables in JavaScript. There's a constant variable and a dynamic variable. Constant variables are set. So once you assign it, its value is not going to change. So if you do my constant equals 5, that's basically what it's going to be for the whole life of the effect. Now if you try and do my constant equals 6, it's going to give you this error. So see that red line? If you hover over it, it'll say cannot assign because it's a constant. If you do want to change a variable, you declare it with the word let. So you can do let my variable equals 5, and then after that you can set it to whatever you want, 6, 7, or throughout your program you can keep changing its value. Okay, and two variables are not allowed to have the same name. So anytime you declare a variable, you give it a different name. This will start making more sense as you start scripting more. So don't worry if it's not super clear right now. All right, so let's get rid of this. Then over here we have the Diagnostics module. That's actually pretty useful and it lets you print stuff out to the screen. So what you can do is diagnostics.log and then type hello world. That's usually the first thing you do when you're learning a new language. And now if I hit save and go back to Spark, if you click on the console, there you can see hello world printed out to the console. And just a note above, you're going to see this error with my constant is read only. That's the constant we had assigned and tried to modify, which is basically, like I said, you're not allowed to do that. But the thing to note is anytime you type in your script and hit Control S or save it, your OS is going to save the file and then Spark is going to pick up that change and try and reload it. So if you're typing along and your script isn't complete and you try and save it, Spark's going to pick up that change and it's going to give you a bunch of errors. So don't get confused if you see a lot of errors when you come back to Spark. So what I usually do is just close Spark, type in my script, and then open it up again. This way you only see the latest or the final version of the script. The other thing you can do is just click on the clear button and then go back to your script, make a change and save it, and then Spark's going to load it again and you'll only see the latest error. Okay, so now I'm going to show you guys how to create a function. So a function in script is basically like a patch group in the patch editor. So in the patch editor, if you create a bunch of nodes and you want to reuse them in a later project or just call it multiple times with inputs and outputs, you can create a patch group. So you take all those nodes and group them into a patch group. Similarly to that, in scripting, if you want to reuse a bunch of code, you put it in a function. So the way to create that is you just type function, and in this case, let's just create a simple print function, which takes in an argument a. So this is the syntax for a function. It starts with the word function, then you give it a name, then in parentheses, you give it the arguments. So it can have as many arguments as you want, a, b, c, d, whatever. In this case, we just want one. And you can call the arguments whatever you want. So what this is going to do is we'll just take diagnostics.log and put it inside this function. So now instead of printing hello world, we can print a, which is whatever was passed into this function. And now we can call this function many times, like print hello, print this is a test. So in this case, it just makes it easier to type because print is shorter than diagnostics.log, but you can put whatever you want in these functions. So over here, you can have as much code as you want. And then one function can call other functions, and you can have this whole graph of functions, which is similar to the patch graph in the patch editor. So, okay. So let's just go to Spark, and there you go. We see, hello, this is a test. And these two hello worlds are there from before. That's no longer in our script. It's a bit annoying that you can't clear this log from the script. Hopefully that'll be added soon, but for now it's like until you clear it or reopen Spark, you'll see your logs from previous runs or anytime you hit save. Okay, so now let's try and create the actual effect we had in script. So I'm just going to delete these. So what I like to do when I create a new effect is to create an entry point function, which is called main. And this serves as the entry point to your effect. You don't actually need this, it just makes it easier to organize the code a bit better. And what we'll do is call this function here. So basically, Spark parses your script line by line. So as it's going through the script, it's going to parse what you type and use that to generate your program. So here it's going to load in the Sine modules, here it's going to load in the diagnostics, here it's going to declare your function, print, and here it's going to declare the main function, but no one's actually using it. This is how you call the function. You type its name, and then in parentheses, you just give it the arguments. This main function doesn't really have any arguments, so it's just going to be, it's just blank. So what'll happen is Spark will reach line 30, then run your main function, go inside here, and then whatever we have here is what'll run next. Alright, so let's go back to our patch and see what we're trying to create. So in the patch editor, what we want to do is take the vertex attributes from the rectangle and feed it into a texture sampler and feed it in the camera texture and the material as the output. So all this stuff is basically in the shaders module. I'm going to do a much more detailed explanation of the shaders module later, but for now, basically, if you're doing any type of image operation or something which involves textures and materials, you're going to be working in the shaders module. So if you go to the Spark AR scripting reference, which was the link I had shown you above, and then you search for the shaders module, it'll give you this documentation for the shaders module, and there's also an example of how the shaders module works. So firstly, we're going to need to require the shaders module and the materials module as well. So let's just bring that in. We're actually not going to need the seed modules for this case, so let's just delete it and then do materials equals require material, and that's just gonna load in the material module. Then you do const shaders require shaders, and then we're also going to need the textures module because we're interfacing with textures, so you do require textures. Alright, so now we have these three modules and we can use that to replicate the effect. So if you go back to this example here, you can see the way to locate the material in the assets is to do material equals materials.get. So we declare a variable which is material0, and that you do materials.get and give it the name. In our case, it was material0. Just a note, and actually there's a red line here, so let's see what that is. Can't find. Oh, so I had named it material, so that's just a typo. So just a note here, this material.get is the old way of loading materials. Starting with Spark, I think version 85 or something, I'm on 86, there's a new way to load objects in the scene, but the syntax is a bit more complicated, so I'll cover that in detail later. But it's the same thing, it's just this way is no longer officially supported, so if you try to launch an effect with this, it'll start working in like 6 months or something. But I'll cover that really soon, so for now just ignore it. And similar to that, if we want to load in the camera texture, we're going to do camera texture equal textures.get, and I think it's called camera texture or camera texture 0. Let's just check. Yeah, it's called camera texture 0. Alright, so now we have the material and the camera texture, which is, so we have this and we have that. What we need to do is sample the texture and acquire the attributes from the rectangle. So basically, anytime you have something in the patch and you're trying to figure out how to do that in the script, go to the scripting module. And in this case, I know it's in the shaders module, so I can just search here, Vertex attribute, and that'll give you the documentation for it. But if you don't know which module it's in, just use the search over here, this search button. And if you type in Vertex attribute, it'll point you to the shaders module. Alright, so how does it work? It says Vertex attribute, and you pass it in a config with a variable name which comes from one of these. So in this case, we want Vertex attributes dot text chords. And the syntax for this is a bit different than other functions because it's using a JSON string. So basically anything in a patch editor which has a dropdown, it's gonna require a config string. So if you go to the example above, there's this example of the gradient, which is similar to the Vertex attribute because it has a dropdown. So if we just take it here, copy it, and we just do const UVs equals shader dot, instead of this we change it to Vertex attribute, and the variable in the string was known as variable name, and then here we do shaders dot Vertex attribute dot text chords. I believe that was it. Vertex. Yeah, so text chords, and that'll basically give us the UVs for the rectangle. Alright, so now what we want to do is sample the texture. So let's go here, we're going to need the texture sampler. So if I go in here and search for sampler, then there we go, we have the texture sampler. So basically this takes in the texture and the UVs, and it returns a scalar or a 0.2D signal. Ignore the, so I'll cover signals in more detail later, but it has to do with reactive programming, and it's just like a signal coming out of a patch. So if you just think about these functions as a patch node, then these things are the inputs and this is the output. So in this case, we'll do color equals shaders dot texture sampler. And I don't know if I mentioned, we have this shaders dot over here. So in scripting, when you have a function in a module, you have to give the name of the module first. So in this case, you'll do shaders dot. You can't just type texture sampler. Like in a patch, you just have texture sampler here, but in script, you have to be more explicit and tell the script where to find this function, because you can have different modules with the same function name. I don't think Spark does, but it's possible. So then we give it a texture, which is going to be the camera texture, and we give it the UVs we had just computed. So now we've basically sampled the texture at the UVs of the rectangle, but we haven't actually done anything with it. So what we want to do is output this to the material. So the way to do that is, if you go back up here to this example, you get the texture slot and then you do material.setTexture with that slot. So let's just copy this. So this gets us the diffuse slot for the texture, because if you look at Spark, we're basically trying to assign to the diffuse texture. So that'll give us the diffuse slot, and the new way to set this is to do material.setTexture slot, and you give it texture slot and the color. So this example over here, this set texture is the old way of doing it. It's also deprecated. So from now on, it's better to use set texture slot. It's the same thing, just different syntax. Okay, and now if we go back to Spark and check the console, there seems to be an error. Cannot read property get of undefined, and it's in line 27. All right, so let's see what line 27 is. It's basically this thing, material.get. Did I type it wrong? It's saying read property get of undefined. So it's saying material is undefined. Oh, we have a red line here. So what does that say? Can I find molecule? Oh, it's probably called materials. Yeah, there we go. Alright, so there's a bit of a typo. So this should have been materials instead of material. I guess that makes sense because the others end in an S as well. And then we just replace. Okay, so if we go to Spark now, okay, we have a bunch of errors. Subclass of, oh sorry, so okay, so it's basically complaining about the camera texture. What we need to do is do camera texture dot signal, and if you hover over signal, it says get the RGB shader signal of the given texture. The signal can then be used in shader computation. So when you load in the texture, it's just a texture object, but if you want to use it in the shaders module, you have to convert it to a signal. So just type the word signal, and I'll explain this in detail later in the reactive programming module, but that just makes it so that you can operate on the texture. All right, so now we should have a working script. I'm just gonna clear this because there's a lot of stuff from before in the log, and those yellow error warnings were about the materials.get I was talking about, which there's a new way to do that. All right, so let's go to the patch editor now, and I'm just gonna delete all this, and we should be able to see undefined is not a function. Line 37. What's it? Line 30 materials dot. Sorry, so it's not. So that's actually, if you look at the example here, you have to call it on the material object. So basically you do material 0.setTexture slot, and there you go. Now we have the actual effect. A note about this, basically you can have certain functions are at the module scope, so you do module.function, and certain functions are at the object scope, which is materials.function. These are known as methods, and the other ones, the ones at the module scope, are basically just global functions, which are stored in that module. It doesn't matter too much. Usually you'll just look at the documentation and it'll tell you where the function needs to be called on, whether it's the object or the module. So just look at the documentation and you'll find out. Okay, so let's go back to Spark, and if you clear. Okay, so now we basically have the same thing we had in the patch editor, but in script. So let's try and actually do something fun with it. Alright, so what we're going to do is load in the Reactive Module. And this lets you interact with reactive objects, which again, I'll cover that in a different video, but it just means it allows you to create those connections we talked about. So if you want to do any math operation, it's in the Reactive Module. So now we can create a modulation color, which to create a color you do reactive.pack4, which creates a 4-channel color, which is RGBA. And let's just create simple red, which is 1001. And then what we can do is multiply. So we create a final color, which is the multiplication of our input color with the modulation color. So now we'll basically give a red tint to our effect, and let's just output that instead of the original color. And now if you go to Spark, there you go. So you have a red tint to the scene. So let's go back and add some simple animation. For that, we can use the time module. I wouldn't recommend using this in an actual effect. For that, it's better to use the animation module, but the time module just gives you like a really quick increment encounter. So what we can do is const gt, which is current time, is time.ms, and that's just the number of milliseconds since your effect has started, since you basically loaded Spark. So it's just a value which is growing bigger and bigger as your effect runs. So now what we can do is take this value and feed it into a sine wave. So sine wave takes an input, which could be anything, and converts it to a value between -1 and 1 in a wave-like fashion. So you can do curve equals reactive.sine. I'll cover curves and all this math stuff in a different video as well. There's a lot of things to explain, I suppose, but for now I just thought I'd do a simple illustration of what you can do with scripting. So we pass in the current time, and sine will give us a value between -1 and 1, but colors, RGB colors, work in the 0 to 1 space. So what we can do is reactive.abs, which will take the absolute value of the sine wave. So instead of going like this, it'll go like this, in basically an M shape. And now we can take that curve and put it in the red channel. So instead of flat red, we'll get a red which fades between black and red. So if you go to Spark, it's more of a flicker, but that time ms is milliseconds, so it's the number of milliseconds which have elapsed. So that's really fast. So what we want to do is scale it down a bit, so we can multiply this by, let's say, 0.001. So that'll convert it to a second, because there's 1,000 milliseconds in a second. So now it'll fade in over a second. There you go. Alright, so I'm going to stop it at that for now. We covered a lot of topics, so I don't want to overwhelm you with information. Hopefully you learned something. If something wasn't clear, or if this was your first time scripting, firstly I would recommend typing it all out and experimenting with the code yourself. It's much easier to learn scripting if you type it out, and the more you practice, the easier it will become. But in case something wasn't clear, just add a question to the comments below and I'll get back to you, or I might even create a follow-up video explaining that topic better. I'll also be doing a lot of videos on advanced topics, so be sure to subscribe if you're interested in that. So once again, thank you for watching, and I'll see you guys next time.